Assalamualaikum and a very good day to my respected supervisor, Prof. Dr. Nuraza and panel if any. I am Siti Mariam, a final year student who would like to present my research project 1. My current research project title is Preparation and Characterization of Cement-Based Composite Produced from Automotive Paint Sludge Ash. Moving on to the Chapter 1 Introduction. As for the research background, waste generation and management is becoming a global challenge, resulting into increased environmental concern. The automotive manufacturing process results in the consumption of several natural sources and the generation of various types of waste. The amount of the paint sludge generated increases every year with the worldwide increase in the production of cars, where inappropriate disposal of paint sludge might be harmful to public health and the environment. This environmental issue has forced the scientists and material designers to focus considerable attention on the development of new class of composite material by taking this industrial waste as reinforcement phase. Waste management and recycle into a sustainable construction material has proved to be an alternative for waste disposal, helping out in the area of environmental pollution. The problem statement in my research would be, the previous studies have shown the feasibility of using biochar as an engineering material in cement-based composite materials. However, according to Gupta, most of the previous studies mainly focus on agro-food industry waste, such as coffee powder, cocoa husk, pellet of parchment coffee, rice husk, hazelnut shells, wheat straw, and waste wood. Paint sludge has a higher ash content comparing with the previous used biochars, relatively lower specific surface area, and porosity with a negligible heavy metal leaching risk. Thus, the use of paint sludge in cement composites still remains a challenge. The objectives of this research are to study the paint sludge effects on the composition and performance of the composite materials, to assess the feasibility of using paint sludge as cementitious or concrete materials, to determine the impacts of the paint sludge solid powder on the hydration of cement paste, compressive strength, and surface microstructure of the composite with the physico-chemical characteristics of sludge amended cementitious composite. For the scope of research, this research will be focused on the preliminary study of the sludge waste on the sludge classifications, its characterization, deep study on the suitable treatment and disposal. Secondly, we'll go through on the types of composite material along with its process making. There are many types of process making of the composite material with different sludge waste. At the end of the day, only one process to be taken for the methodology. Next, research on the automotive manufacturing plants with its formation and compositions that might harm the environment or surrounding. To further the research, study on the cement-based composite material is taken in order getting full information and good data for making or enhancing the cement composite using paint sludge as one of the material prepared, where it is obtained from the white goods industry. The purpose of the current study is to recycle automotive paint sludge waste, which is an abundant hazardous side product in several sectors, into a valuable concrete product. Also, the impacts of the paint sludge solid powder on the Let's proceed to the chapter 2, which is the literature review. In this chapter 2, I divided into 3 subtopics, which are 2.1, the sludge waste, subtopic 2.2, the composite material, subtopic 2.3, the automotive manufacturing plant. As for the subtopic 2.1, which is the sludge waste, consists of the classification of wastewater sludge, which are raw or primary sludge, activated sludge, digested sludge, and humus sludge. Next, it consists of sludge characterization. The sludge form is composed of organic and inorganic matter in solid, liquid, and gaseous forms, the composition of which differs in terms of physical, chemical, and biological characteristics. It contains mainly minerals such as quartz, calcite, or microline. These minerals are formed by elements like ferrum, calcium, and magnesium. Heavy metals such as chromium, nickel, copper, and mercury can also be found in the sludge. Next, this subtopic also consists of sludge treatment and disposal, which the objectives are reduction in the volume of sludge for disposal by removing some of the water, as collection of byproducts which may be used or sold to offset some of the cost of sludge treatment. for disposal of the sludge in a safe and aesthetically acceptable manner, destruction of pathogenic organisms, and stabilization of the organic matter contained in the sludge. Sludge treatment and disposal at any particular location may comprise any or all of the methods stated, which are concentration, the reduction in the volume of sludge to be treated by encouraging the sludge to compact to a higher solids content; treatment, to stabilize organic matter, which is destroy pathogens or yield byproducts; dewatering and drying, which is the removal of water, thus reducing sludge volume. Sludges with less than 80% moisture content are usually spreadable. Last would be the disposal. The only place where sludge can be disposed of are into the air, onto land or water. Whether or not the impact on the receiving environment is legally, aesthetically, and ecologically acceptable depends on both the degree of treatment provided and the method of dispersing the sludge into the environment. However, all of the disposal method will lead to the environmental impact, which are the contaminants and pathogens from the sludge waste, climate change, freshwater and marine eutrophication, acidification. For topic 2.2 is distributed to two parts, which are type of composite material from sludge and type of process. For the type of composite from sludge, one is sludge utilization in cement production. It is investigated the use potential of digested and dewatered sludge within the production of cement-like material. The results showed that sludge cement was found to possess high water demand and quick setting time compared to ordinary cement. Secondly, the sludge incorporation in brick and ceramic production. As researcher Abdul produced bricks using sewage sludge as a staple, the physical and mechanical properties of the bricks were tested, where the results showed that the products met the specified standard. Next is sludge utilization in manufacturing lightweight aggregates. As researcher Cho explored the possible use of mixture of sintered waste sludge and sludge ash for synthetic aggregate processing. The findings revealed that for the manufacture of standard weight aggregate, the blend of sewage, sludge ash, and clay was stronger. Lastly, sludge usage as raw material for concrete and mortar. The strength of concrete samples with sludge was tested by YAC, and the findings revealed that the sludge concrete is much like reference concrete with longevity. Some of the process making would be pyrolysis. Pyrolysis technology is an attractive alternative to realize the solid waste recycling and energy utilization. Next is composite fabrication, which is the casting. According to Abhilash Purohit, epoxy-based thermoset composites are fabricated by solution casting technique, which involves placing the uncured material into or onto a mold. Other is sintering, the process of compacting and forming a solid mass of material by heat or pressure without melting it to the point of liquefaction. Last would be the catalytic pyrolysis. It was found that pyrolytic char containing silica and carbon structure could interact with metal materials to form stable bonds, which could effectively prevent the loss of active substances to enhance the catalytic performance. Last subtopic is automotive manufacturing plants. How paint sludge is formed? So basically, during painting process, vehicle bodies are placed during a spray booth, and the spraying of the water-based and solvent-based paints is administered during a series. This painting process generates waste since vehicle body is sprayed, and through this spraying process, there is overspray during which the sprayed paint did not reach the target. This oversprayed paint will attend downward to the undersection of spray booth with the existence of airflow system downdraft provided inside the spray booth. As items are painted in this booth, a particular amount of paint does not contact the article being painted and forms a fine mist of paint within the air surrounding the article. The overspray paint, washed with the existence of continuously circulating water curtains, passes through the ground grating system and is collected during a sludge pit located under the booth. This mixture of water and overspray paint is named paint sludge. The paint sludge is removed periodically or continuously from the spray booth. Paint sludge is usually considered to be hazardous. However, the composition of the sludge may vary due to the differences within the paints used. Paint sludge has the potential to be ecologically harmful. It has been reported that the paint sludge samples were classified with toxicity classes 2, which is toxic within the toxicity test, algae test, bacteria contact test, and plant test. Last chapter is the methodology. Firstly, as for the material preparation, paint sludge has been collected from the Automotive manufacturing company in Malaysia, which is in a solid form. Next, it undergoes high energy mining process. This is the process to grind the paint sludge into a very fine particles approximately into 90 micrometer. Then the paint sludge ash or powder is being characterized with some analysis, which are Fourier transform infrared for analysis of composition of samples used to identify organic, polymeric, and in some cases inorganic materials. Next will be the X-ray diffractometer, which is to analyze the structure of materials from the scattering pattern produced by a beam of X-ray interacting with the particle. This is then matched to an existing database to determine the chemical components within the material. Next will be micropore surface area, BET. This is for surface area measurement and pore size analysis. Next is field emission scanning electron microscopy, which is to visualize a very small topographic details on the surface or entire or fraction objects. Last will be particle size distribution, which is to determine and report information about the size and range of particles representative of a given material. After that is the preparation of the cement paste, where the cement is being replaced with the paint ash by molding process using a VCAD apparatus. Last but not least, we'll do the physical analysis, which is the testing for the compressive test to see how good the cement is and to discuss whether the cement can be replaced with paint ash that can act as a fine filler to reinforce the strength of cement. That's all for me. Thank you.